yesterday when some of you, I said not to freak out when you got to the answer key if you were seeing this absolute value stuff. You had everything else right. Your exponents were good, your coefficients were good, everything else is great. But what the heck is going on with these absolute value things? So here's the easier, I guess I'll call it, way to look at that. When you're breaking down radicals, if you have an even index, okay, square root, fourth root, sixth root, something like that, and you don't see the words assume all variables or all values are positive, we have to think a little bit. So here's how this works. Because you may look at, these are two of the problems off of the practice yesterday. You're like, okay, they both have even index, cool. One of them has absolute value and one of them does not. Why? Here's the simple reason. If when you break them out, 16 divided by 4 is 4, 24 divided by 4 is 6. If they break out as an even exponent, 4 and 6 are even, you don't need the absolute value. Because even if the value were negative, when it's even, it's going to become positive. If you square a negative number, it becomes positive, or a fourth, or a sixth. However, if when you broke out of the radical like you did on 21, 4 divided by 4 is 1, that's not even. 4 goes into 7 one time with 3 left over. If you come out here and your exponents are odd, 1, 3, 5, something like that, that's where the absolute value comes into play. Because if this were negative, that would change the value of the problem. Now, if that's the only thing you're foggy on with yesterday, you're in good shape, okay? That's something we can clean up as we see it again later in the week, when we see it on the quiz preview, and we keep looking at it that way. But that's the easiest way to look at that. And I'm probably going to put that up on the board when we get into practice time today, so you can kind of take note of that if you want to make that a little bit easier. But for the time being, put this back over to the side for the moment, we are going to chat operations with radical expressions. Now, you've already gotten a preview to this before when we were back in 114. We chatted a little bit. We've done simplifying a square root, okay? We factor out the squares, use the product property to isolate it and simplify. So, we've chatted about how you have to make sure that your denominator has a radical in it. We've got to rationalize it if that happens. So here's the basic rules of thumb. And I'm going to actually add one thing back up here. I'm not trying to get some of you like seasick. Product property of radicals. We mentioned this before. We're going to mention it again. We're going to multiply any coefficients, just a fancy word for the numbers without variables. And we're going to add exponents. So whenever you're multiplying and everything is underneath the radical, multiply the big numbers together, add the little ones together. And that's kind of the easiest way to keep track of these. And then we can go into what we were doing before with our simplifying. Again, otherwise we can get into all these fancy words and things, and it really doesn't do a whole lot for us. So, first one. Instead of trying to break these down separately, let's go ahead and find the product right away. So, you multiply the coefficients. You add the exponents, if the variable's the same, of course. And once you're down to one radical, now we're going to break it down. Square root of 36 is a perfect square. It's just 6. Remember, if you don't see an index out here, it's 2. 2 goes into 4 2 times. There's no remainder. I'm done. Now, you might have been able to notice, I purposefully didn't say it. We've said before, if you have 2 of the same radical, basically the radical just cancels out and leaves you with what's underneath. That's what happened here. They were both 6x squareds. The squareds basically wipe each other out and leave you with what's underneath. But that doesn't happen all the time. Next one, same thing. Multiply the coefficients. Add the exponents. Not much different from the last one. So I go, okay, let's see here. That's going to be 6. 2 goes into 7 3 times. So let's see. 2 goes into 7 3 times. I got 1 left. Oh, Hardy, I know. You've got to put the absolute value around the x to the third because even and odd. Hang on. Okay, so when I said that before, that I meant that. If you have in the instructions that you can assume the value of the variable is positive, you don't have to put the absolute value. Would it be wrong if you did? No, because absolute value isn't going to change this, especially if it's positive already. But be aware of that, because that could save you some stress of having to ask yourself that question when you're moving ahead. Okay, let's see here. Ooh. Okay, here's where we're trying to fool you, but you're not going to get fooled. Taking something to the 1/2 power is the same thing as taking its square root. Because remember from yesterday when we were talking about these, you know, if I don't see an exponent, it's 1. If I don't see an index, it's 2. And if I want to go from radical to exponent form, we just do exponent over root. I slip myself. Exponent over index. So these are actually the same thing. So this is really just 15x to the 4th y squared, if you wanted to look at them in the same way. So just like number 1, just like number 2, we're going to do the same thing. We're going to multiply the coefficients. We're going to add exponents when they have the same base. Like, that's the only x I see. But my y's, I can add those up. And so now, I'm ready to go into breakdown mode. So I look, 75 is not a perfect square. What goes into 75 that's a perfect square? 25. So we got 25 and we got 3. So they still got to multiply to 75. Square root of 25 is 5. I left myself nowhere near enough room here. The 3 stays under. 2 goes into 4 twice. 2 goes into 8 4 times. Neither of them have any remainder. So the only thing I had under the radical was that 3 from when I broke down my coefficient. Everything else, good to go. So as long as you remember multiply coefficients and add exponents, the breakdown is going to be the same as what we've seen before. Now, when you get to division, it gets a little more interesting. So here, bless you. So here, when we get to the quotient property, we're going to divide the coefficients and we're going to subtract the exponents until we get it down to 1 radical. Then we'll do it the same way we did with the multiply. We're basically just using exponent rules. We're just using them in a radical. The exponent rules are going to be coming back again here too. So when I get here, I'm like, all right, so let's see here. 54 divided by 6 is 9. Remember, if you don't see an exponent there, it's still there. It's a 1. 4 minus 1 is 3. 6 minus 4 is 2. And now we're right back where we have been with the other problems. Square root of 9 is perfect. 2 goes into 3 one whole time. There's 1 left. So how many times does it go in? Its remainder. 2 goes into 2 once. There's no remainder. And I'm off and running. Try and divide this out a little better. So let's see. Ooh. Everything's been a square so far. Let's get a cube in. Remember, 1/3 cubed root, same thing. Just like here, 1/2 square root, same thing. So we're going to still just go ahead. The 216 I'm going to leave alone for a minute. 9 minus 6 is 3. And I'll get people here going, wait a minute. Why are you like ignoring the 1/3? Don't you distribute that? Doesn't that become 3? Again, this is just looking in this same radical form. Don't get fooled by seeing the exponent and thinking, oh, there we go, that you've got to go a different direction. So if I rewrote it this way, you wouldn't think about distributing that right away. You'd be like, oh, yeah, that's under the radical. I just subtract these. So if you need to rewrite it as a radical, that's not a terrible idea. Cubed root of 216, if you don't know, is perfect. It's 6. 3 divided by 3 is 1. That's it. Once we get it into this single one, it's just dividing on the exponents. How many times does it go in and break down that radical? So, oh dear, he's going to do it on this one, isn't he? I am. I'm freezing. Let's try out number 6 here. Remember that 1/3 is just a cubed root, just like we did on number 5. So kind of rewrite, follow your rules. Remember, you're dealing with a cube when you're dealing with your coefficient. Don't be looking in the squares column. That will not help you. Take a deeper look at a couple of things here. Biggest thing with this one that tends to get The variables usually end up okay. It's the coefficient. Because again, we get that 54, and we're so used to seeing this be square that I'll see tons of people with 9 and 6, 9 and 6. But here's the issue. It's a cube. You've got to work in this column, so 27 is the number we're looking for. 27 and 2 get me to 54, but the 27 in its cubic form will break down to 3. The 2 stays underneath. Keep watching your index, because that makes a difference, not only for what you're dividing by, but for when you're breaking down your radicals too. Keep that sheet handy. Okay, now we are going to get into the weird with division. Okay, one more thing we're going to add up here in this part just to help out. So we cannot when you are done, when you get to your final answer, when you're dividing, you cannot at any point, and that's why I put X out here instead of a number, you cannot have a radical in your denominator's answer. It doesn't matter if it's even, odd, doesn't matter. We've got to rationalize, and we've done that before, but it's just a reminder here. So here's what I mean. This is where it gets a little more interesting. I look at number 7 and I'm like, well, 8 divided by 45, math, enter, it's still 8 over 45, what the heck? Now, can I break these down separately? Absolutely. So that's what we're going to do. So first things first, let's see what we can do here. Square root of 8. What's that going to look like broken down? Okay, so 2 and 4. Let me get this out of my way. So we got 2. 2 goes into 2 once. So 2x, square root of 2 up in the numerator. All right. Then what about 45? 9 and 5. So 3y squared, because 2 goes into 5 twice. And then we've got the 5 and our one leftover y in the denominator. This is a problem. So we have to fix this. So what we're going to do, I'm just going to rewrite this for a second because I need a little bit of room here. Okay. Whatever this radical is, if it's a square root, square roots aren't hard to deal with. We're going to multiply the numerator and denominator by whatever that radical in the denominator is. Because that's how we're going to make it go away. This will be the last step, though. So when I multiply across, the stuff under the radical, I can multiply together. You can have the weirdest radicals in the world in the numerator of your fraction, and it is A-OK. Now here's where I got to think a little bit. Let me forget about this for a second. If you multiply the same radical by itself, it basically just makes the radical go away. So this has just become 3y squared times 5y. So 3 times 5 is 15. Y squared times y is y cubed. There is no longer a radical in the denominator. And that weird looking thing is actually the final answer. I'm good. Now, if there would have been something going on out here, if this would have been 3 over 15, where you can reduce the fraction, I'd have to do that. If somehow I'd have ended up with y and y cubed out here, I'd have to reduce that. But that might have been taken care of in the step before. So anytime it's a square root, we like square roots. I'll show you why in a second. whatever this radical is in the denominator, just do numerator and denominator by it. And that's going to take care of it and fix it for you. But if it turns into something else, oh boy, we're going to star number 8 here. This is the nastiest thing you'll run into. I'll warn you in advance. Because when we get into cubes, here's the dilemma we're going to run into. So, let's break this down first. So 3 goes into 5 once with 2 left over. 3 goes into 3 once. Okay, that wasn't bad. We get that part done. 40. Remember, not squares, cubes. What cube is going to go into 40? 8. 8 and 5. Perfect. So the cubed root of 8 is 2, but the 5 does not break down. Now, initially, we're going to be like, okay, I got this. I'm going to multiply the numerator and denominator by the cubed root of 5, and I'm going to be good. Here's the problem. If I do the cubed root of 5 times the cubed root of 5, I get the cubed root of 25. Well, why is that a problem? Because if I look at my perfect cubes list, do you see 25 anywhere on there? No. So that's not going to work. You're like, well, what the heck do we do? Okay, so here's what the new plan is. I got to multiply that 5 by something that's going to get me one of these cubes so it breaks down. So I start to look, and I'm like, 8, no. 5 times something gets 64, no. Ooh, wait a minute. 5 times what would get me to 125? I heard it. 25. So we're going to multiply the numerator and denominator by the cubed root of 25. When it gets bigger than squares, you have to think ahead. So, oh my gosh, what is this going to look like? All right, let's see here. So we've got PQ cubed root, multiply the stuff underneath, 25p squared. That's kind of funky looking. My denominator. Okay, we're going to write it out fully this time. So 2 times the cubed root of 125. 5 times 25, just like we figured out a minute ago. And now it becomes more clear to see why that works. I'm not going to do a thing to the numerator. That big bunch of crazy is the actual answer. But here, the cubed root of 125 is 5, so this is 2 times 5, which is 10. I'm done. This, I would say the other thing that gets people on this, especially like when we get to a quiz or something, they want to keep going. They're like, well, wait a minute. Can I add the exponents? No, this is under a radical. This isn't. Well, I can break down 25 over 10. No, this is under a radical. This isn't. You've got to get to a point that you just trust. Once you rationalize your denominator, almost every time you're going to be completely done. So that was the bad. We'll finish with the good, and then I'm going to feel confident that we're going to be okay here. So, could I break down something? Yeah, I could break that down a little bit. So, all right. I can get 1g out. 1g. The 2 doesn't get out. My leftover g doesn't get out. That I can't do a darn thing with. Okay. It's a square root. Hallelujah. It's a square root, so I can just brainlessly go along and go, all right. Whatever that is, I'm just going to multiply by it. That's how we're going to get out of this. So, let's see. What's that leave me with? So I got g 10g z over. Remember, if you recognize that they're the same, they just cancel. Okay? Otherwise, you could say 25z squared and then break it down, but you don't really need to. The only stuff you possibly ever have to look at to break down is this stuff outside. If there's not something there that works, that's as far as you go. So don't make it harder on yourself. Oofda. That's a little something right there. Again, just got to watch out for those cubes. So, we'll have the same chats we always do. 3 and 4. Hardy, can I do odds? Sure, but don't skip the factoring problems. See them again. Factoring is not going away again now, probably seriously, until like Unit 6. And we're in the middle of Unit 1. So it's just something we got to learn to live with and practice and keep going with. You do evens. You can do that there, but do